Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0171 indicates that the fuel system is running too lean, which means there is not enough fuel being injected into the engine relative to the amount of air. This specific code is triggered when the mass airflow MAF sensor detects an air-fuel mixture that is too rich or too lean. In this case, it suggests a lean condition. The affected components include the MAF sensor, which measures the airflow entering the engine, and multiple sensors that can influence the fuel system's performance. In the Honda Accord models from 2008 to 2012, the MAF sensor is typically located in the intake manifold before the throttle body. Understanding and addressing the P0171 code is crucial for optimal engine performance and fuel efficiency. The P0171 code signifies a fuel system too lean condition, where the engine is receiving insufficient fuel for the amount of air entering the combustion chamber. The MAF sensor plays a vital role in this process, as it measures the volume and density of air entering the engine, helping the Engine Control Unit (ECU) calculate how much fuel to inject for optimal combustion. Located in the intake manifold, typically before the throttle body, the MAF sensor can be influenced by various environmental factors, including debris or damage from foreign elements. Other components relevant to this code involve various sensors such as the manifold absolute pressure (MAP) sensor and the air-fuel ratio (AF) sensors. If any of these sensors malfunction, they can directly affect fuel delivery, causing a lean condition that triggers the P0171 code. Several factors can contribute to the P0171 code being triggered. First, issues with the MAF sensor, such as debris obstructing its function, can lead to incorrect air measurements and, consequently, a lean fuel mixture. Second, vacuum leaks in hoses or seals connecting components can allow excess air into the intake, again, affecting the air-fuel ratio. Additionally, problems with fuel delivery, such as a failing fuel pump or clogged fuel injectors, also impact the system's performance, leading to insufficient fuel. It's essential to systematically check these components to identify and rectify the underlying issue, throwing the P0171 code. Prioritizing these checks can help ensure accurate diagnostics and repairs. When the P017 code is triggered, drivers may notice a range of symptoms indicative of a lean fuel condition. A rough idle may occur as the engine struggles to maintain a consistent speed due to the incorrect air-fuel mixture. Additionally, poor acceleration is common, as insufficient fuel can affect the vehicle's responsiveness when the throttle is applied. Lastly, you may observe increased fuel consumption as the engine compensates for the lean condition, often leading to inefficient fuel usage. Noticing these symptoms early can prompt timely diagnostics, preventing further damage to the engine or other components. The first step in troubleshooting the P0171 code involves confirming the failure at idle conditions. Start by monitoring the AFFB, which stands for Air-Fuel Feedback Short-Term Fuel Trim, using the Honda Diagnostic System HDS. It's critical to let the engine idle without any load. For automatic models, put the transmission in park or neutral, and for manual, shift into neutral. If the AFFB reads 1.15 or higher, it indicates that the short-term fuel trim is too high, which suggests a lean condition requiring further investigation. Conversely, if the AFFB shows normal readings at idle, proceed to the next diagnostic step to assess the onboard snapshot parameters. In this second troubleshooting step, you will review the onboard diagnostics OBD snapshot taken when the AFFB was at its lowest value. It's essential to document parameters such as engine speed, vehicle speed, VSS, relative throttle position, coolant levels, and accelerator pedal position during this snapshot. After recording these values, drive the vehicle under conditions similar to the OBD snapshot to monitor the AF/FB again. If it remains 1.15 or higher, it confirms a persistent lean fuel condition that warrants further inspection. If the AF/FB is within normal limits, the system is currently functioning correctly, and no immediate action is required. The third step addresses potential interference with the MAF sensor by checking for debris. Begin by carefully removing the MAF sensor from its housing, taking care to avoid damaging any components. Once removed, inspect it for lint, bugs, dirt, or any foreign objects that may obstruct airflow. If you find debris, clear it away and use a vacuum cleaner to clean the air cleaner housing as well. After cleaning, reinstall the MAF sensor and proceed to the next diagnostic step. This step is crucial because any obstruction can skew the readings from the MAF sensor, leading to erroneous adjustments in fuel delivery from the engine control unit. In this fourth step, you will inspect all related components for any disconnections or damage. This includes visually examining the crankcase breather hose, intake air duct, oil cap, dipstick, and air cleaner housing for cracks or disconnections. These components play pivotal roles in maintaining the proper air-fuel mixture by ensuring a sealed intake system. If any hoses are disconnected or show signs of wear, repair or replace them as necessary. A damaged component can create a vacuum leak, which contributes to the lean condition indicated by the P0171 code. For the fifth step, start the engine and let it idle. Using the HDS Honda Diagnostic System, set up a high-speed snapshot for the AF/FB. Next, pinch the vacuum hose connected to the engine mount, allowing you to monitor the AF/FB while the hose is pinched. If the AF/FB still reads 1.15 or higher, it indicates that the vacuum-controlled engine mount is functioning properly without leaks. However, if it drops below 1.15, a leak in the vacuum-controlled system is indicated. Check the vacuum hoses and the control solenoid for any leaks, and if no leaks are found, you may need to replace the front vacuum-controlled engine mount to resolve the issue. Step 6 involves inspecting the brake booster for potential leaks. With the engine still idling, pinch the vacuum hose that connects the brake booster to the intake manifold. This step allows for the monitoring of the AF/FB while the hose is pinched. If the AF/FB continues to read 1.15 or higher, the brake booster system is not leaking, indicating its proper functionality. Conversely, if the value drops when pinching the hose, it suggests a leak within the brake booster system or its associated hoses. In such cases, check all vacuum hoses for any defects and, if necessary, replace the brake booster to eliminate the leak. The seventh step involves checking the positive crankcase ventilation (PCV) system. Start by letting the engine idle and pinching the PCV vacuum hose that connects to the intake manifold. During this process, monitor the AF/FB value. If it remains 1.15 or higher, it indicates the PCV system is functioning as intended. If the AF/FB reading drops, however, it signals a leak in the PCV system. In such an event, inspect all related vacuum hoses for cracks or damage and perform repairs as needed. The PCV system is crucial for removing harmful gases from the crankcase. Thus, maintaining its integrity is essential for engine health. In this 8th troubleshooting step, you'll be inspecting the EVAP, Evaporative Emission Control Canister Purge System. With the engine still idling, pinch the vacuum hose connecting the EVAP canister purge valve to the throttle body. This will help monitor the AFFB value while the hose is pinched. If the AFFB reads 1.15 or more, the evap canister purge valve and hose are operating correctly without any leaks. However, if the reading drops, a leak in the evap canister purge valve or hose is then indicated. Check the relevant hoses for any signs of wear or damage, and make necessary repairs to ensure the system's proper operation for reducing emissions. Step 9 focuses on monitoring the MAF sensor's performance. Start the engine and maintain the speed at approximately 3,000 RPM until the radiator fan activates. Ensure that the engine coolant temperature, ECT, sensor is above 158 degrees Fahrenheit, 70 degrees Celsius, and all loads are turned off. With the engine at a stable 2,500 RPM, use the HDS to check the MAF sensor readings. For an 08 to 11 Accord L4 automatic transmission, the expected reading should fall between 6.5 to 9.1 grams per second, GM/, while manual transmission models should see readings between 5.6 to 7.8 GM/. If these readings are compliant, the MAF sensor is functioning normally. However, if they are outside specifications, further investigation and potential replacement of the MAF IAT sensor is warranted. In Step 10, you'll check the fuel pressure in accordance with the AFFB values observed. It's important to measure fuel pressure under the same conditions that triggered the P0171 fault. For the 08 to 11 Accord L4 models, fuel pressure should fall within 48 to 55 psi, while for the TSX models, the range remains the same. If the measured pressure meets these specifications, it suggests that the fuel delivery system is functioning correctly. In contrast, if the pressure is not within this range, the next course of action will be to replace the fuel tank unit to rectify fuel delivery issues that could lead to a lean condition. Step 11 directs focus towards checking for vacuum leaks in the intake manifold. To execute this, you will disconnect the intake air duct from the air cleaner housing and connect a large intake manifold adapter cone from the OTC LeakMaster Evaporative Emissions System Tester Kit. This will allow you to inject smoke into the intake manifold. As the smoke flows, inspect all critical areas, such as the intake manifold and gaskets, throttle body and gasket, EGR, exhaust gas recirculation valve gasket, air intake ducting, and various vacuum and air hoses. Any visible signs of smoke escaping indicates a leak that must be repaired to restore the integrity of the air-fuel mixture. In the 12th step, you will focus on the fuel injectors, which are vital for delivering the correct amount of fuel into the engine. Replace the existing fuel injectors with known good injectors and then operate the vehicle under the same conditions that caused the AFFB to read 1.15 or more. If the AFFB continues to indicate a lean condition, it suggests that the issues are not stemming from the fuel injectors. If, however, the value drops, this confirms that the previous fuel injectors were at fault for the lean condition, and you will need to proceed with confirming the repair. Step 13 centers on replacing the air-fuel AF sensor, another critical component in regulating the air-fuel mixture. Begin by replacing the malfunctioning AF sensor with a known good sensor. Then drive the vehicle under the same testing conditions where the AFFB was previously observed as too high. After replacement, check to see if the AFFB still reads 1.15 or higher. If it does, this suggests that the AF sensor was not the source of the problem. However, if the reading confirms a drop, it would indicate that the AF sensor was contributing to the fuel mix issue, prompting a successful resolution. The 14th troubleshooting step focuses on the fuel quality, as poor quality fuel can lead to lean conditions in the engine. If misfires or the P0171 code appeared soon after refueling, remove the fuel tank unit and drain it completely. Afterwards, refill the tank with known good fuel to ensure that only high-quality fuel is present. Drive the vehicle under the same conditions used earlier while monitoring the AFFB. If the reading still indicates a high value of 1.15 or more, the fuel quality was not the cause. If the number drops, however, it signifies that the previous fuel used was contributing to the lean condition. In the final troubleshooting step, you will confirm that the repair has addressed the P0171 issue. First, turn the ignition switch to the on position and reset the engine control module, ECM, or powertrain control module, PCM, with the HDS. Following the reset, perform the ECM-PCM idle learn procedure to ensure the system recalibrates itself. Start the engine, maintaining a speed of about 3,000 RPMs without any load until the radiator fan activates. Then let it idle. Finally, assess the AFFB under the same conditions that previously indicated a value of 1.15 or more. If it now falls within normal limits, the repair has been successful, confirming that the fuel system is now functioning correctly. Once repairs are executed, it is essential to perform a final verification to ensure everything is operating smoothly. Begin by ensuring the system operates as intended and there's no intermittent malfunction that can cause problems in the future. Clear the diagnostic trouble codes from the memory of the ECM. Next, conduct a test drive to replicate operating conditions and assess the vehicle's performance. This allows for a real-time evaluation of the repairs, confirming that the adjustments made have resolved the P0171 issue effectively. If the diagnostic tool displays no new or persisting fault codes, the repair is verified as successful. Engaging in preventive maintenance can greatly reduce the likelihood of encountering the P0171 code in the future. Regular inspections of the mass airflow MAF sensor and cleaning it to remove any accumulated debris or contaminants is essential. Additionally, checking vacuum hoses and connections periodically ensures that they remain intact, minimizing risks of leaks that can affect air-fuel ratios. Using quality fuel consistently will also help maintain engine performance and reduce the chance of misfires or lean conditions. Establishing this routine can promote the longevity of your vehicle's engine and maintain optimal fuel efficiency. In conclusion, understanding Diagnostic Trouble Code P0171 is crucial for maintaining the health of your Honda Accord from 2008 to 2012. Monitoring critical components like the MAF sensor and ensuring the fuel and vacuum systems are functioning correctly will help address and prevent lean fuel issues. The troubleshooting steps outlined will assist technicians in pinpointing the root cause of the code effectively. Finally, regular preventive maintenance plays an essential role in reducing future occurrences, assisting vehicle owners in enjoying a smoother and more efficient driving experience. Quick actions taken now can save time and cost later, ensuring reliable vehicle performance. Please like and subscribe to the channel. See you next time.